Hello student, welcome to the lecture on utility analysis of consumer demand, and after this lecture we will be able to learn the following objectives. Describe the meaning of utility, explain the law of diminishing marginal utility DMU, explain the law of EQUIP-MARGINAL utility, talk about the indifference curves. Let us start with the introduction of utility analysis of consumer demand. Analysis of the determination of prices of goods and services in the market is an indispensable part of the subject matter of economic theory. When an economy is guided by a market mechanism, prices are determined by interaction between demand and supply forces. That is, they are the result of an interaction between decisions taken by buyers and sellers. This is so at all levels of prices, right from the price of an individual good to where all prices are considered simultaneously. To analyze the determination of all prices simultaneously is obviously a very complex task and can be handled only in stages. Therefore, one begins with a small part of the problem and extends the findings in stages to the economy as a whole. It goes without saying that at each stage, both demand and supply sides have to be studied and analyzed. Demand for a good by a consumer is not the same thing as his desire to buy it. A desire becomes a demand only when it is effective, which means that given the price of the good, the consumer should be both willing and able to pay for the quantity which he wants to buy. Thus, one notes that an individual's demand for a good should be considered in the following manner. One can assume that the consumer's decisions are guided by several considerations such as his income, taste and preferences, etc., and further assume that these remain constant and do not vary. Thus, other things remaining the same, we note that with a change in the price of the good, the consumer changes the quantity purchased by him. Normally, the consumer buys more of a good when its price falls and reduces the quantity when its price increases. The quantity demanded must be related to the time interval over which it is purchased. For example, it is meaningless to say that a consumer buys 5 kg of sugar when its price is ₹12 per kg. We must know whether the quantity bought is per day, per week, per month, or over some other period. Demand for a good by an individual or the market as a whole is conventionally expressed in 3 alternative forms, namely a demand function, a demand schedule, and a demand curve. Let us find out about each of these in depth. Demand function. A demand function of an individual buyer is an algebraic form of expressing his demand behavior. In it, the quantity demanded per period of time is expressed as a function of several variables. A demand function may be in a generalized form or a specific form. Demand schedule. It is a tabular form of describing the shifts in quantity demanded of a good in response to shifts in its per price unit. While all non-price determining variables remains unchanged, a demand schedule has 2 columns, namely price per unit of the good Px and second quantity demanded per unit Dx. The demand schedule is a set of pairs of values of Px and Dx. The first column records the hypothetical values of Px and the second column records the corresponding quantity Ox which the consumer would decide to buy if faced by that price. Demand curve. It is a graphic representation of the demand schedule. It is a locus of pairs of per unit prices Px and the corresponding demand quantities Dx. The basic difference between a demand schedule and a demand curve is that in the former, Px and Dx are discrete variables. Their values vary in discrete steps and not continuously in the case of a demand curve. However, both Px and Ox are assumed to be continuous variables. As a result, the demand curve is continuous without gaps. 2 approaches have been very popular in analyzing the demand behavior of a typical individual consumer, namely those based upon the concepts of utility and indifference curves. Let us know more on the demand curve.
So let's talk about demand. Even though it's good to want things, in economic terms, that's not enough to be able to say that you actually demand something. Formally speaking, demand is defined as being willing, ready, and able to purchase a particular item. So if you really want it but you can't afford it, you don't really demand it. If you want to buy it tomorrow, you still don't demand. Ready, willing, and able. The thing that we don't distinguish is how you're able to pay for something. We don't know whether you have cash up front, whether you're paying for it on your credit card, whatever it may be. We just say that you have the funds in some way to make this transaction happen. We can define demand as either individual demand, how much one person wants, is ready to purchase, and is able to purchase of an item. Or we can talk about market demand, the sum of the demand for all of the individuals in a given market. You'll notice that there's an important time element to the concept of demand. The number of ice cream cones, for example, that I demand would depend on whether I'm talking about ice cream cones in a given day, probably less than one, or in a given week, maybe one or two. In a given year, you would keep getting different numbers depending on what time units you put on demand. Now, economists are often sloppy and we don't explicitly put that into the axis of our graph, but it's important to remember that it is always there. This time element also makes it more logical to say things like, I'm demanding 2.5 ice cream cones. To say, for example, I'm demanding 2.5 ice cream cones per week would really just mean that I'm demanding 5 ice cream cones every 2 weeks. The general rule we have about demand, which is referred to as the law of demand, is that all else being equal, individuals demand more of a given item as it gets cheaper. So for example, I'm going to demand more ice cream if the ice cream costs $3 per cone than I would if the ice cream cost $5 per cone. The important thing to remember here is that when we're thinking about the price to a consumer, we're taking into account all of the different components of price the consumer has to pay, including things like taxes, surcharges, required maintenance costs, etc. In a behavioral sense, consumers might not treat all of these different aspects of price the same, but for the basic model, we're at least going to start with the assumption that the consumer internalizes all of those different components of price. When we talk about a demand curve, what we're really referring to is a graph of price versus quantity demanded. You'll notice here that I labeled both a lowercase q and an uppercase q. The distinction that we make in economics a lot of the time is that we use the lowercase q to refer to individual demands, and we use the uppercase q to refer to market demand. The same concepts are going to hold when we talk about individual supply versus market supply. So let's think about a demand curve represented by the equation quantity demanded is equal to 40 minus 5p. The first thing we want to do is say, well, how do we graph this on our axes here? You'll notice that the way that we wrote this demand curve is a little bit different from what you may have seen in your math classes, because we have the variable on the x-axis as a function of the variable on the y-axis. This is just a convention in economics, and it gets very frustrating sometimes, but it is what it is, and you can't really fight the trend at this point. So we're just going to think about, well, how can we go about plotting this even though it is in somewhat of a strange form? For a demand curve, the easiest thing to do is just think about what the different intercepts are. So you'll notice that the point on the p-axis here is the point where quantity is equal to 0. So we can go over to our equation and think about, well, if quantity is 0, what is the corresponding price? Well, if quantity is 0, then we just have 40 minus 5p equals 0. Or 5p equals 40, p equals 8. So when quantity is equal to 0, p is equal to 8. And we can put a point, maybe write something like this. Now let's think about the other side of this. The point over here on the q-axis of our demand curve is the point where price is equal to 0. So let's think about where that has to be. Well, if price is equal to 0, quantity demanded is just equal to 40 minus 0, or 40. Notice I'm not really drawing to scale, it's not usually very important. We can see from the form of our equation that this is just going to represent a line on our price and quantity axes. So we can just connect these 2 points. Notice here you get a downward sloping line, which isn't surprising given the law of demand that we talked about earlier. As the price of an item goes up, consumers are demanding less of it, or vice versa, as the price of an item goes down, consumers are demanding more. Notice here that we're holding everything else that could possibly impact demand. I'll come back and talk about this in a little while, things like income, tastes, expectations. We're holding all of those things constant and just thinking about how price affects quantity demanded. Let's think about what the slope of this demand curve is. We say that slope is represented by the change of whatever is on the y-axis divided by the change in whatever is on the x-axis. So in this case, we could say that the slope is equal to the change in P divided by the change in Q. Or, say, 8 minus 0 divided by 0 minus 40, which is negative 1/5. You'll notice that when we have the law of demand being satisfied, we get a demand curve that has a negative slope, which corresponds to the demand curve sloping downwards like we see here. In theory, we could have a demand curve that would slope upwards, and we do have names for those type of things, but in practice those examples are very hard to find, so we can say that in the vast majority of cases, demand curves in fact do go in this direction. One other thing that's helpful to note is that when we talk about moving from one point to another point on the same demand curve, we refer to this as a change in quantity demanded. In other words, when we have a change in price that causes us to move from one point to another, we say that this is a change in quantity demanded. We'll see how this differs from a change in demand, which we're going to talk about in the next lecture. Let's say you're super stubborn and say, I need my demand curve to look like it does in my math classes because otherwise I really don't understand what's going on, it's all too confusing. One thing you can do is you can rewrite the demand curve as we see here, and we can just solve for price so that we in fact do have the variable on the y-axis in terms of the variable on the x-axis. In this case, we would just go through and put P on the left-hand side and say 5P is equal to 40 minus quantity demanded. We would then divide through by 5 to get that price is equal to 8 minus 1/5 times the quantity demanded. This is referred to as the inverse demand curve, and it really answers the question, for any given quantity, what is the price that we can charge such that we have that many customers lining up at the door? Whereas the regular demand curve says for any given price, how many units of that item are demanded. We're not really trying to imply a causal relationship in one way or the other, we're rather just trying to say that price and quantity are correlated in this way. Once you have the demand curve like you see it in your math class, it's pretty straightforward how it relates to the graph that we see here.
Meaning of utility. We shall now learn the meaning of utility. Utility is want or pleasure, satisfying characteristic of a good or service. Utility is measured in units of measurement called units. Utility analysis is the investigation of how consumers reach decision to achieve utility maximization. Utility is measured ordinarily. Utility of a good is its expected capacity to satisfy a human want. To a consumer, the utility of a good is a satisfaction which he expects from its consumption. It is the extent to which it is expected to satisfy his want. It is obvious that utility of a good to a consumer can differ from the satisfaction which he actually derives from its consumption. The fact that utility of a good is a satisfaction which the consumer expects from its consumption implies that it is a subjective thing. Now we shall talk on utility versus realized satisfaction. A consumer demands a good on the basis of its utility, that is, expected satisfaction, and not on the basis of actual satisfaction derived from it. Measurement of utility. The need for measuring utility arises so that it can be used in the analysis of demand behavior of individual consumers and therefore of the market as a whole. The basic of the reasoning is that a consumer compares the utility of a good with the price he has to pay for it. Let us now find out the concepts of total and marginal utility. Total utility is the total amount of utility one derives from consuming goods or services. Total utility decreases or diminishes over time. Look at this example here for better understanding. Now, marginal utility is the amount of additional utility the person receives from the consumption of additional unit of a good or service. Marginal utility is equal to the change in total utility divided by change in number of units of consumption.
The formula, what we're really interested in is the marginal utility. The marginal utility is really the amount of additional utility one derives from the consumption of goods and services. You can think of this in terms of the ratio of the benefit, that is utility, divided by the number of units of consumption. So there's a couple of formulas. First is the way many economists like to write the formula. Marginal utility is equal to the change in total utility divided by the change in the number of units of consumption. The little triangle stands in for the words change in. Another way to write the same formula is to write the words change in utility divided by the change in number of units consumed. Finally, the mathematical way, the way of actually calculating marginal utility, is that we need to have two levels of utility called T1 and T2 and two levels of consumption.
Now let us find out more on utility.
As consumers, we make choices every day about what and how much to buy and use. In order to model how consumers make these decisions, economists traditionally assume that people make choices that maximize their levels of happiness. Economists even have their own word for happiness. Utility is the amount of happiness gained from consuming a good or service. This concept of economic utility has some specific properties that are important to keep in mind. If consuming a good confers positive utility on a consumer, consuming that good makes the consumer happier. In other words, positive utility numbers are, well, positive. Conversely, negative utility numbers associated with consuming a good indicate that consuming that good makes the consumer less happy. The greater the utility number, the more happiness the consumer receives from consuming an item. This is consistent with the last point, since large negative numbers are smaller, or less than, small negative numbers, and being a lot unhappy is worse than being a little unhappy. Utility numbers can be compared, but it doesn't necessarily make sense to perform calculations with them. In other words, while it is the case that a utility of 6 is better than a utility of 3, it's not necessarily the case that a utility of 6 is twice as good as a utility of 3. Similarly, it's not necessarily the case that a utility of 2 and a utility of 3 would add to a utility of 5. Economists use the concept of utility to model consumers' preferences, since it stands to reason that consumers prefer items that give them higher levels of utility. The consumer's decision regarding what to consume, therefore, boils down to answering the question, what affordable combination of goods and services gives me the most happiness? In the utility maximization model, the affordable part of the question is represented by a budget constraint, and the happiness part is represented by what are known as indifference curves. We'll examine each of these in turn and then put them together to arrive at the consumer's optimal consumption.
Law of Diminishing Marginal Utility DMU. Let us now talk on the Law of Diminishing Marginal Utility DMU. To understand Law of Diminishing Marginal Utility DMU, let us see this video.
One day, he asked to his mother a very innocent question.
Mom, a very new thing happened to me in yesterday's party. There were free pastries available and my friend and myself had a bet on who can eat more pastries. I thought that I will certainly win this bet because, as you know, I have a sweet tooth for pastries. However, things went in a different way. I was excited before I started, enjoyed the initial few, but over a period of time, my excitement went down, and after some time, I started hating the pastries. Does your economics have an answer for this behavior of mine?
Well, certainly yes. And it's very simple and intuitive to understand. Let's recapitulate the experience you got there. Let's first look at the first pastry you consumed. You loved the pastry because you derived satisfaction out of it, a feeling of overall sense of well-being. Just like pastries, you might derive certain satisfaction out of eating, say, cookies or a burger. And depending on your constitution, you may derive different amount of satisfaction out of these different things. Let's define a concept of utility that measures the amount of satisfaction you get by eating these things. Knowing you, I am sure you derive maximum satisfaction out of pastry as compared to burger or a cookie. Let's say you derive 10 units of satisfaction from eating pastry, 5 units of satisfaction by eating cookies, and 8 units of satisfaction by eating a burger when you are hungry. So, if you eat all of these, your total utility by eating all of these would be 10 plus 5 plus 8, which is equal to 23. There is another concept called marginal utility, which comes into effect when you eat more of the same, which was the case in your binge at the party. Marginal utility signifies the additional utilities or units of satisfaction you derive when you eat additional unit of the same product. Let's replay how it went with you in the party with the introduction of the utility and marginal utility concepts. You loved pastry number 1 because you were hungry and the pastry really hit the spot. You were hungry and had an appetite for sweets. Hence, it was very fulfilling. It added 10 satisfaction units to your overall sense of well-being. So, the total utility you consumed was 10, and the marginal utility was also 10 because it was your first piece. Pastry number 2 was good, but not as good as pastry number 1 because your hunger and need for sweets was already partly fulfilled. So second pastry added a little less, that is, say 8 units to your overall sense of well-being. So, the total utility increased to 18, 10 plus 8. But the marginal utility, the incremental utility derived by eating the additional piece of the same, decreased from 10 to 8. Pastry number 3, still good, but you started to fill up. So it adds only 5 units to the sense of well-being. So total utility now is 23, 18 plus 5. But the marginal utility decreased to 5 from 8. Pastry number 4, Your stomach was now full, and this pastry added much less to your overall sense of well-being. So it adds only 2 to your overall satisfaction level. Total utility 25. Marginal utility 2. Till this stage, there is an increment in the overall satisfaction level with every addition eat, as the total utility is increasing. However, please notice that the marginal utility decreased over time. Pastry number 5 did not make you any happier, so there is no incremental increase in satisfaction level. Total utility remained the same as 25. Marginal utility therefore, however, decreased to 0. Pastry number 6. You feel reluctant to eat more because you are fed up of it and you hate it by now. By eating it, you're actually decreasing your sense of happiness. Here, the marginal utility is negative, say -3, due to which total utility now decreased to 22 now. Yes, you had reached a stage where incremental eating led to a decrease in your overall happiness. Let's summarize it in the table below. As can be seen, when the same product and service is consumed again and again, total utility increases initially. The incremental increase in the utility, that is marginal utility, generally decreases over time.
Now we shall talk about the uses of the law of DMU. The concept of marginal utility of a good and the manner in which it changes in relation to a change in its stock with the typical consumer plays a central role in demand analysis. It is directly linked with the price which the consumer is ready to pay for different quantities of the good under consideration. The relationship between diminishing marginal utility of a good and its price helps us in explaining the determination of its price in the market. The law of DMU can be extended to the case where a consumer is faced with a decision to divide his total expenditure over a number of goods. Given the law of DMU, economic rationality of the consumer leads us to the conclusion to define and measure consumer surplus, which is defined as the excess of the maximum price which is the consumer is ready to pay for the good over the price which he actually pays for it. The law of DMU is highly useful to the authorities also in working out their social welfare programs. They can take steps by which goods and services are allocated between members of the society in such a way that marginal utility of each good or services tends to be the same for every individual. Law or EQUIP-MARGINAL utility. Let us now talk about the law of EQUIP-MARGINAL utility. The law of diminishing marginal utility plays a crucial role in explaining the demand behavior of a typical consumer. It is clear that the consumer equilibrium will change if there is a change in his total expenditure, marginal utility schedule of any good or price of any good. Consumer's equilibrium is the solution of this problem. It describes the respective quantities of goods A, B, C, N which the consumer buys. The law of EQUIP-MARGINAL utility describes the rule by which the consumer takes this decision. Okay, now let us talk about the limitation of the law of EQUIP-MARGINAL utility. In reality, the law of EQUIP-MARGINAL utility suffers from several limitations which comes in the way of its implementation by the consumer. The goods on which the consumer spends his money are perfectly divisible. The law also suffers from the unrealistic nature of its other assumption. One such assumption is that the consumer has complete knowledge of the prices and availability of all consumer goods. The law assumes independence of utility schedules of goods. It means that utility derived from one good is not affected by the quantity purchased of other goods. Now we shall on the derivation of law of demand utility analysis. Law of demand describes the changes in the market demand for a good in relation to its alternative prices. It says that in normal situation, quantity demanded of a good falls when its price increases and vice versa. In other words, the quantity demanded and the price of a good are inversely related to each other. Utility approach helps us in deriving the law of demand. For this purpose, we start with the law of diminishing marginal utility and the marginal utility curve of a consumer good X as in figure. We measure A, units of good X along X-axis, and B, units of marginal utility of X, MUX, along Y-axis, and draw the marginal utility curve of X, MUX. Thus, for example, point P on the MUX curve shows that the consumer derives PM units of marginal utility when he buys OM units of X. In other words, the marginal utility of OMth unit of X equals PM. Similarly, in case the consumer buys OM units of X, then his marginal utility falls to PM. Indifference curves. Now we shall have a discussion on indifferent curves. Utility approach suffers from several drawbacks. For this reason, a consumer demand curve derived with the help of the utility approach also suffers from similar drawbacks. In particular, mention may be made of the assumption of constant marginal utility of money and cardinal measurement of utility, as also its inability to handle the case of inferior goods and income effect. The technique of indifference curves tries to avoid these drawbacks and provide a technically superior analysis of demand. Assuming that there are two goods X and Y having their respective utility schedules for consumer, an indifference schedule represents all those combination of two goods from which the consumer expects to derive a same total satisfaction. A graphic presentation of an indifference schedule yields an indifference curve. It represents all those combination of two goods X and Y from which the consumer expects to derive same total satisfaction. Let's talk about the properties of indifference curves. Indifference curves slopes downward from left to right. Indifference curves are convex to origin. Indifference curves do not intersect each other, and higher indifference curve represent higher level of satisfaction. Budget price line BPL. In indifference curves approach to demand analysis, budget price line BPL plays an integral role in the determination of consumers' equilibrium. It is a straight line joining 2 points on y-axis and x-axis and has a negative slope. Its starting point on y-axis represents the amount of y that can be bought with given label and price of y, PY. Its end point on x-axis represents the maximum amount of x which consumer can buy with given income and price of x, PX. Now let us learn more on indifference curves.
To try and explain, so I'm going to give it a go. Indifference curves are convex to the origin, and they link points. Every point on this indifference curve delivers equal satisfaction or utility to a consumer whose indifference curve it is. What do I mean by that? Well, let's imagine that we have on the vertical axis food, and we have on the horizontal axis cars. Every point on this indifference curve links a combination of food and cars. For example, point A, here we are, this is point A. It might represent 10 units of food and 2 units of cars. And point B might represent 3 units of food and 6 units of cars. We know, because of this indifference curve, we know that point A gives as much satisfaction or utility as point B does to the owner of this indifference curve, which we will call I1. So, if offered 10 units of food and 2 units of cars, and an alternative combination of 3 foods and 6 cars, it would make no difference to the owner of this indifference curve whether they were given combination of food and cars A or combination B. They are therefore linked on the indifference curve. Now I want to show you in a little sub-diagram here why indifference curves are not linear. That is wrong. They must be convex to the origin, and the reason is this, and I will go back to the bigger diagram to show you this. At lower and lower and lower units of food, it takes bigger and bigger quantities of cars to satisfy the loss of another unit of food. Let me show you. If they reduce food from 10 to 9, the loss of the 10th unit of food can be satisfied with a small increase in the quantity of cars. Because food is relatively plentiful when there is 10 being reduced to 9. But reduce the food from 3 to 2, and you see that it takes a bigger increase in cars to satisfy the loss of a precious third unit of food. From 3 down to 2 is in fact, after all, if you think about it, a loss of 1/3 of their food. Because going from 3 to 2 is a loss of 1 out of 3, whereas the loss of 1 unit of food up here represented a loss of only 10% of their food. So as the food becomes scarcer, it takes a bigger and bigger quantity of cars to satisfy, taking it down to 1 unit of food, and we find that it takes a huge increase in cars to satisfy the loss of the second unit of food. So they must be shaped this way. As 1 unit gets scarcer and the other more abundant, it takes a huge amount of that one to satisfy the loss of a very precious unit here. Okay, what's the use? What's the application of these indifference curves? Well, I should also point out that, of course, indifference curve 2 represents units, combinations of food and cars, all of the same to each other. The owner of the indifference curve is indifferent to these combinations, and this combination, and this combination. But all of those points must be better, must give more satisfaction than all of the points on I1. So an I curve further out, I3, I4, represents a level of satisfaction. Although all the points on that curve are the same satisfaction, they are all better levels of utility or satisfaction than all of the points on I3, which in turn are better than all the points on I2. To show you why it must be better, just think of this. All of these points represent 10 units of food, but more and more and more cars. So you can see why that point is better than that point. It's the same amount of 10 units of food, but more cars, but this point is even less cars, this point is even less cars. So it's clear that this point, let's call that Z is better than Y must be better than X is better than A, and given that all the points on this curve are the same as A, then they must all be inferior choices to all the points which are on this curve, which are all equal to X, since X is better than A. So all the points on a further out I curve must be better than all the points on an I curve further in. And of course I curves cannot cross, because that would imply that they were of equal satisfaction. So they are completely separate, these I curves. Now, the application of these I curves is as follows. Let me get a different coloured piece of chalk. In a little sub-diagram, let me just remind you that the budget lines, or PPFs for a country, production possibility frontiers, are drawn like this. They are linear. In fact, PPFs are probably concave to the origin, but I'm going to draw it as a budget line where there is a fixed amount of income for a household who can afford only so much food and so many cars. And let's draw that in on the big diagram. Let's imagine that this is the budget line. If they spend all their money on food, they can have that much food. If they spend all their money on cars with no food, they can have that many cars. Or they can have some combination of the two, substituting one for the other. And I'm going to draw that budget line in like that. It's clear that any point on I4 is impossible. They represent combinations of food and cars which cannot be attained given their budget. But what can be attained is these points easily, all along here on I1, and almost a point on I2. If I redraw I2 very slightly, let's have it coming in like this, you can see that there is a point here, a combination of food and cars, which can be afforded within the budget of this household. Because all the points on I2, including this point, let's call this point W, including combination W, food and cars, are all equal satisfaction and are all better than all the points on I1, it stands to reason that a household will achieve, will spend its budget according to this combination of W, which is, I don't know, it could be 7 foods and 5 cars. Because 7 foods and 5 cars being on I2 must be better than this spending of the money, or this spending of the money, or this spending of the money, which are on I1. So what a budget line combined with indifference curves tells us is, it actually tells us how a household will best allocate its resources. The budget line tells us what they can afford. The I-curves link points and show us relative levels of satisfaction between combinations of goods. And by connecting the two, and there are all these other sub-I-curves in here, there's always I-curves everywhere, this is the furthest out I-curve that this budget can reach. It's the best combination of goods. Now, if they were to receive an increase in their budget, if they got an income rise, and it shifted their budget line out to here, they would be able to achieve a point on a further out I-curve. And if they continue to get increases in income, then they can continue to achieve combinations of goods represented by points on higher I-curves. And in fact, as their income increases, we would be able to trace a path which showed the way their spending changed as their income rose. And we might find that the spending on one particular item, perhaps food, wouldn't rise as quickly as the spending on another item like cars. We might see this start to bend round, which would imply that the income elasticity of demand for cars is greater than the income elasticity of demand for food. As their income rose, their spending on food didn't rise so much. As their income rose, their spending on cars rose more quickly. So, you know, then we're getting into it quite a lot there. It's quite a busy diagram already, but I hope you see that indifference curve analysis gets us through this problem of not knowing what combination of goods on a budget line. Even though the budget line tells us what's affordable, it doesn't tell us what's preferable. And with utility analysis and indifference curve analysis, we are able to start plotting not just what's possible, but what's preferable.
Summary. Now in the end, let us summarize what we have learned in this lecture. A demand function of an individual buyer is an algebraic form of expressing his demand behavior. The position of equilibrium is attained by the consumer where his budget price line is tangent to one of his indifference curves. Law of demand describes the changes in the market demand for a good in relation to its alternative prices. The law makes a questionable assumption that the consumer is able to accurately determine the marginal utility schedules of all the goods. A consumer demands a good on the basis of its utility, that is, expected satisfaction, and not on the basis of actual satisfaction derived from it.